In this video, we'll talk about how to compute a mean, and I'm going to show an interesting property about means. And while it's a pretty easy topic for you, I'm hoping to give you a much faster, insightful way using that property of means in the end. So for starters, let's say you've got four different numbers, 81, 92, 89, and 86, and you would like to compute the mean of those numbers. Well, in the standard way of dealing this, you know that the mean, or most of you call it the average, mean is a little bit more precise, and since this is variable x, we will say the mean of that is x with a bar over it, x bar. And you know you're just supposed to add up all of the numbers and divide by the number of terms, or in math notation, I'll just use a sigma for sigma notation over the number of terms. And in this case, if you were to add up those four numbers, then you get 348. There are four of them, and so the mean in this case is 87. Not a difficult problem. You've probably been doing that one for years. So a property I would like us to be able to play with now is residuals. Residual is just the distance from the mean. We just computed that the mean of this data set was 87, so let's figure out how far each one is. Now residuals are going to be assigned numbers, not just the distance, but I need to know the distance in what direction. So 81 is 6 units below 87, so I will say its residual is minus 6. 92 is 5 units above, so its residual is plus 5. 89 is plus 2. 86 is minus 1. So all we're doing here is just figuring out how far each number in the original data set is from the mean of the data set, and you use a negative if the data point was below the mean and a positive if the data point is above the mean. Now here's a really interesting piece. What would happen if you add up, find the sum of all those residuals? Well, in this case I get negative 6 and negative 1 is negative 7, plus 5 and plus 2 is positive 7. The sum of the residuals is 0. That's curious. I wonder if that holds in all cases. Let me shift over to the calculator. So a quick repeat of what we just did. I've got the four numbers here in my TI Inspire, and there are the numbers, and if I wanted to, I could find the mean of a list of numbers. So mean is a function, so mean of that list, and we get the 87 that we predicted before. But this time I'm going to find the residuals, which is each data point less the mean. And there are the four numbers that we had before, and when you compute the sum of those numbers, we get the 0 just like we did by hand. So I wonder if this is always true. So how about I just do a random selection of numbers just to prove that I'm not having anything at all to do with this. Let's go from 1 to, I don't know, 87, and let's pick 10 of them. And what I have now is a random list of 10 numbers. Let's find the mean of those numbers, and that's 46. And now let's take all of those numbers and subtract off the mean. So what I'm doing is I'm computing the residuals of those numbers, and there are all of those, and let's now compute the sum of all of the residuals. Now remember, these were 10 random numbers just from 1 to 87. And again, I get the sum of residuals equals 0. And that turns out to be a pretty important property for all means. So what we can say from the example we computed by hand and the example we confirmed on the calculator is that it seems like whenever I've got a data set and I want to find the sum of all of the residuals, it turns out that if I take every data point x sub I, where x1 through xn are all the data points, and subtract the mean, that sum is always going to turn out to be 0. All right? That is actually going to open us up to another way to find a solution to our first problem. Let's find the mean of all of those numbers. Well, I have no idea what that mean is right now. 86 looks like it's somewhere in the middle. Why don't I just assume the mean is 86? Well, if so, then all of the residuals from 86, starting with 81, 81 would be down 5. And notice here, all I did is make a guess at what the mean was. I had no idea. I'm pretending I don't know. 92 is 6 above. 89 is 3 above, and 86 is 0 off. I guess that was the mean. So overall, when I add those up, I get a plus 4 divided by 4 units, because I've got 4 separate data points, is an average value of being off by plus 1. If I take my assumption and how far off it was on average, then I am now at 87, which is the mean, 86 plus 1. So maybe picking a data point in there was just a fluke. Let's say I'm going to guess that the mean was 90. Let's again compute all of the residuals. So if my sum is 90, then my 81 was off by 9, and my 92 is 2 above. My 89 is 1 below. My 86 is 4 below. So when I add up all of those, I get minus 10 minus 14 plus 2 is a total of minus 12. Spread over the 4 numbers is a minus 3. If I take my assumed 90 and my average off, 90 minus 3 is 87. It turns out that if I understand that the sum of residuals is always equal to 0, then I can just compute how far off all of the data points are, and I'll get the mean in exactly one shot. So this brings me to one final problem. I'm going to go back to a problem that you guys have probably seen from middle school, someplace for your first algebra course, and I'm going to make an old routine problem so much easier than it was before. So let's say we've got those 4 scores that we've been dealing with all along, 81, 92, 89, 86, and those are 4 test scores that you've gotten in a class, and you would really love your average to be 90, and you've got one more test to go. What does your last test have to be in order to get an average of 90? Well, the traditional way of dealing with this is to say, well, how about I take my 81, my 92, my 89, my 86, and whatever my last score has to be, and if I add all those up and divide by 5, I should get a 90, and then I can just do a little bit of algebra and solve for x. All right, that's certainly true, but I think that's way too much work. So let's find a far more clever way of doing this. If your mean is indeed 90, then the sum of the residuals for whatever x has to be has to add up to 0. So let's compute all of our residuals. From 90, 81 is 9 below, 92 is 2 above, 89 is 1 below, 86 is 4 below, and x, I have no idea what that is yet. But what I can know is so far my residuals are minus 7, minus 8, minus 12. So whatever this guy is has to be 12 above so that I get a total sum of residuals of 0. From 90, 12 above is 102. So you need 102 on your last test in order to get an overall average of 90. I hope there's an extra credit.